Let's take this example for this circuit. Let's take it outside. So here is the circuit. So the switch was off and then it will be on. Switch was off and then it's on. So let us see how the circuit look like before you change the switch. So here the switch is not connected, so it look like this. So actually you have the two circuits are separated here. Okay. So this is how the circuit look like. This is how the circuit look like. And when you see this u of t means that it is 1 at t equals 0. Before that it was 0. So it was 0 and suddenly it will be 1. Of course here you have to multiply it by 30. But this is u of t. If you have u of negative t, this means that it was 1 and then at t equals 0 it is 0. So here it is, look like this. So it was 1 at t equals 0, it will be 0. Here's 1. The other one, u of t, is opposite. It was 0 and then after that it will be 1. So according to this one here, this means that this source was on, okay, before t equals 0. So according to this voltage here is 30 volt. So you can just say this one here is 30 volt because we are talking about t less than 0, 30 volt. Okay, R equal 20, I believe. R equal 20. Okay, so this is just 20. So let us calculate the initial voltage and initial current, which is the final values here. Of course, according to this inductor here is just short circuit, so the current is just 4 ampere, of course. This 4 ampere will continue in this direction, 4 ampere. This makes sense. The capacitor will be open circuit. You remove the capacitor and you add an open circuit. So the voltage across the capacitor is the voltage across this R here, this 20 ohm. This one. So this is VC or V. Okay, so of course this equals the current time what? Time 20. The current is what here? 30 divided by this current equals 30 divided by 20 plus 20, which is 40. 30 divided by 40. 30 divided by 40, which is 3/4, 0.75. Okay, and if you want to calculate V will be the current time 20 will be 15 volt. So this is just 15 volt. Okay, which makes sense because now, of course, 30 volt divided between two resistors, two equal resistors. It doesn't matter what is the value of R. So 30 will be divided equally. So it will be 15 here and 15 here. So this is the initial value. Let us remove this part here. And let us see how can we calculate V dot and I dot. So what's the value for V dot and I dot? We need to calculate this after you turn the switch on. So how the circuit look like after you turn on the switch? See how the circuit look like. Okay. So try to imagine how the circuit look like. First, the switch is on. We need to draw this to when put all the data to make the problem easy for us. So the switch is on, so it's connected. Okay. The source is off. Now the source is off because, as I said, this is U negative T. This means that for positive T it will be 0. So this will be 0, 0. And remember that the voltage source, when you turn it off, it's a short circuit. It's not open circuit. So don't leave it like this. The voltage source, you turn it off, it's a short circuit. So here's the circuit. Okay. Second, we need to add the initial values. I was 4 ampere, so this was 4 ampere. So this is 4 ampere. So let's add it here. And the voltage across the capacitor was 15 volt. So let me put it here in different value. 15 volt. Okay, as I said, this one will not change. These values will not change suddenly. Okay, so once you change the switch, these values will remain for or instantaneously. Okay, so now we need to find V dot and I dot according to this circuit. So first we draw the circuit and put all the data and then calculate V dot and I dot. Okay, V dot, we get it from what? From IC divided by C. IC divided by C. And this one, I dot, you get it from VL divided by L. Of course, as a time of 0. So we need to find the IC and VL. IC is the current in the capacitor here. This current. This is IC. Okay. So IC equal what here? IC equal what? We need to calculate it. To calculate it, you need to use Kirchhoff current law because you don't have any other way to find it except by Kirchhoff current law. So here you have all this is just one node. This one, and this one, and this one. You have 5 branches here in parallel. This 4 ampere, 20 Henry, R, 8 millifarad, and R. All of them are parallel to each other. So you just need to calculate the current using Kirchhoff current law. And for VL, VL is this voltage here. Need to calculate the voltage here. This is VL. So VL here is easier here. Why? Because the voltage between these 2 points here, this one and the other point on the other side, is the same like this one, same like this one, because they are all parallel here, right? So the voltage across the capacitor is 15. I know that this 15. So 15 will be applied directly on the inductor. The voltage across the capacitor is 15. So it will be the same on R, the same on L. So VL is just 15 volt. 15 volt divided by L, which is 20. Okay, that's 3/4. 0.75. Okay, so this is VL divided by L, which will give you I dot. Let us see IC. IC, I can get it from Kirchhoff current law, as I said. You have 5 branches, so you just use this green, for example, color, and say, okay, all the currents exiting this node here, this big node, this one here. This is, as I said, this is only all one node. They are all connected. So we have this current, plus this current, plus this current, plus this current, plus this current, all are 0. Okay, so if you want to calculate this current, the first current is -4 ampere. Okay, because the current source is opposite to this green current. The second current is what? Is 4 ampere. Is it 4? Yes, it is 4, because it is given here. It's 4 ampere. See? Positive 4. Plus. Next current is this IR. What's IR? IR equal what? Equal 15 volt. The voltage is 15 divided by R. R is 20. So IR equal the voltage divided by resistance. The voltage is 15 divided by resistance is 20 plus. Next current is IC, which is the one that I need. This one here, this current, which I need now. Last one, oh, I'm sorry, here it's supposed to be. Next one, and last one is the current in the last resistor, the second resistor, will be also voltage divided by resistance. The voltage across this resistance is what? Is the same, 15 volt. So it is 15 divided by R, which is 20. Okay, all this equals 0. This is Kirchhoff current law. So according to this, you just need to calculate IC. Of course, this positive and negative 4 will cancel. 15 divided by 20 is 3/4. So 3/4 and 3/4 is 1.5. Then IC is negative 1.5 equal negative 1.5 ampere. So you just need to add it here, negative 1.5 ampere divided by whatever the value for C. C equal 8 millifarad. Here it is. So it will be 8, which is 0.008. This is 8 milli. Okay, so you calculate this value here, whatever the value is. Okay, if you want to calculate it, it is negative 1.5 divided by 0.008 equal 187.5, and don't forget the negative sign. There's a negative sign. So this is V dot and I dot. Now let us look at the circuit at infinity, how it looked like. So here's the same circuit again. So again, this is the same circuit. At infinity, remember that this one was short circuit. So let us connect this one here. This one is short circuit. Okay, and this was connected like this. The inductor will be short circuit. The inductor will be short circuit. Okay, the capacitor will be open circuit. So you remove the capacitor and add an open circuit like this. Okay, so now what you need to do is to find V infinity. This is a voltage here. This is V infinity. And IL, this IL, the current. You don't have inductors. Inductor will be short circuit. So it's very clear that you don't have anything in the right hand side. You just have this short circuit, and this is another short circuit. No, this one is just a resistor here. So this short circuit will cancel this resistor, and will cancel the other resistor also, because they are all in parallel. R and R now are in parallel, and they are parallel with the short circuit created by the inductor. So 4 ampere will pass through this one here. The current will pass through the short circuit. So I infinity is 4 ampere. And V infinity is the voltage across what? Now you have a short circuit. You short the resistor. And V is the voltage across this R. R is shorted now. So it is the current times 0, short circuit. So it is 0, just 0. So this is the solution of this problem.